first show you number 1, and then I'm going to give you 10 minutes to talk through 2 and 3 with your group. All right, while driving on the tollway, Mr. Gobble gets stuck behind a slow driver who's going 22 meters per second. He finally gets a spot in the passing lane, hits the gas, and speeds up to 38 meters per second in 4.3 seconds. All right, so the new way that we learned to solve problems yesterday is to use our equations. And I told you kind of like a few steps to try and do that. Step number 1 is to draw a picture. So there's my picture, Mr. Gobble's car on the road. You always want to put the initial position, or 0, 0, sorry, somewhere, the origin, somewhere in your picture. And when you can, it's best to put it where the object starts. So that's where I put 0, 0. Then we got to list our variables, and we need 4 of them before you pick an equation. Well, we see that Mr. Gobble's car starts at 0 because that's where we put it in the picture. We know he's initially going 22 meters per second. That's his initial velocity. We know he ends up going 38 meters per second to get past that car, and he does that in 4.3 seconds. We don't know anything about how far he travels or what his acceleration is. If we want to know his final position, we realize that both of our equations have 2 unknowns in them, x final and acceleration. So we first need to solve for acceleration, and we can do it using this equation right here. V final equals AT plus V initial. We know the final velocity is 38, the time is 4.3, and the initial velocity was 22. Algebra and solve for the acceleration. Then now that we have acceleration, we plug it into this equation, which is final position equals 1/2 AT squared plus V initial t plus initial position. So we plug in our acceleration, our time, don't forget to square it, our initial velocity, our time, and our initial position. And we solve for the final position. It turns out he drove 129 meters while passing that car. But we also know that we're able to solve problems using graphs. So over here, we make a little graph. We know he's going 22 meters per second, and he ends going 38 meters per second. So this red line is the graph over here. What I did is we know that on a velocity time graph, the area of the graph is your displacement. So if we just find the area of this graph, we'll find his displacement. So I split this into 2 shapes, a rectangle and a triangle. The triangle we know is 1/2 base times height. The base is from here to here, which is 4.3 seconds, and the height is from here to here, which is 16 meters per second. And then we multiply it out, and we find that the area of the triangle is 34.4 meters. We know that a rectangle's area is length times width, so the length is 4.3 meters. The width is 22 meters per, 43 seconds. The width is 22 meters per second. Multiply them out, we get 94.6. This 34.4 plus that 94.6 gives us, of course, the same answer, 129 meters. Because in physics, there's more than one way to solve a problem. And in this class, there are 3 targets: mathematical, graphical, and verbal, or explanations.